The morning of June 13th, 1943, Second Lieutenant Hobert Roach of the 358th Fighter Squadron advanced his throttle and lifted his P-47 Thunderbolt from the English airfield at Steeple Morden, leading his flight across the Channel toward occupied France. The mission was routine, another fighter sweep over enemy territory, the kind of operation that American pilots flew daily as part of the intensifying air campaign against the Reich. But this mission would end differently. Low on fuel, scanning the ground below for landmarks that might guide him back to England, he spotted what appeared to be a friendly airfield. The relief must have been immediate. He could land, refuel, and find his way home. The approach was clean, the touchdown smooth. He followed the ground vehicle that appeared to guide him to parking, shut down his engine, and only then realized his catastrophic mistake. The airfield wasn't in southern England. It was Caen, deep in German-occupied France. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. And the men approaching his aircraft with drawn weapons wore feldgrau, not olive drab. Lieutenant Roach climbed from his cockpit and became a prisoner of war. But his aircraft, a Republic P-47 decoded YFU and nicknamed Beetle, was about to begin a second career that would profoundly disturb the assumptions held by some of the Luftwaffe's most experienced combat pilots. The Germans who surrounded Beetle that morning understood immediately what they'd captured. This wasn't a twisted wreck requiring months of reconstruction. This was a complete flyable example of the massive American fighter that had been appearing over Europe in growing numbers, and the aircraft their pilots kept encountering in combat and couldn't seem to shake off once it got behind them. The recovery operation moved with practiced efficiency. German salvage teams had perfected the art of recovering crashed Allied aircraft across occupied Europe, operating under the direction of specialized Berge Bataillon, salvage battalions tasked specifically with retrieving enemy aircraft for intelligence purposes. They understood that captured aircraft drew Allied fighter sweeps like blood draws sharks, so speed was essential. Within hours, Beetle was being prepared for transport inland, away from the coast, where roaming Allied fighters might destroy it before it could be studied. The Thunderbolt travelled east toward Rechlin, the Luftwaffe's primary testing and evaluation facility, located approximately 100 kilometers northwest of Berlin, near the Mecklenburg Lakes. Rechlin wasn't just any airfield. On February 26, 1936, following orders from Wehrmacht General Feldmarschall Werner von Blomberg, Rechlin had been designated the official central testing ground of the Luftwaffe, the nerve center where German aviation intelligence operated. By mid-1943, Rechlin had become a surreal museum of the air war's competing philosophies. American Bdix Sept flying fortress sat alongside captured British Spitfires and Soviet Yak fighters, creating a bizarre tableau where enemy aircraft wore German markings and stood in neat rows beside Messerschmitt prototypes and Focke-Wulf fighters. The facility sprawled across a massive turf-surfaced aerodrome bounded by a hexagonal perimeter road that defined an area roughly 1,700 meters across. There were no paved runways in the traditional sense, just open grass fields where test pilots could land experimental aircraft from any direction the wind demanded. Supporting the main airfield were 4 clusters of specialized buildings. The northern complex handled administrative support and pilot facilities. The southern area concentrated on engine testing and development. The eastern section managed munitions and weapons evaluation. The western quarter housed technical laboratories and barracks for the engineering staff and test pilots. A dedicated railway line connected Rechlin directly to the national rail network, allowing efficient transport of aircraft components, equipment, and personnel from across occupied Europe. This infrastructure enabled Rechlin's technicians to maintain what aviation historians would later consider among the most reliable sources of aircraft performance data from the entire war. Beetle's arrival generated immediate interest among the technical staff. The Luftwaffe had been receiving troubling combat reports about American fighters for months, particularly these massive Thunderbolts that seemed to possess capabilities German pilots found difficult to believe. Luftwaffe pilots reported engaging P-47 in combat, achieving what should have been decisive advantages, only to watch the American fighters simply accelerate away in dives that left pursuing Messerschmitts and Focke-Wulfs behind. Other pilots claimed they'd shot at diving Thunderbolts and simply couldn't keep up, even though their own fighters were lighter and theoretically more maneuverable. The reports created skepticism among Luftwaffe intelligence officers. German design philosophy had always emphasized lightweight construction and superior power-to-weight ratios. The notion that a 7-ton fighter powered by a radial engine could outdive purpose-built German interceptors seemed to contradict basic aerodynamic principles. But the reports kept accumulating. Pilots didn't simply claim the P-47 was fast in level flight. They specifically emphasized its diving performance, its ability to build speed in a descent faster than anything the Luftwaffe flew, and maintain control at velocities where German fighters became unmanageable. The Rechlin technical team needed answers. If the P-47 truly possessed revolutionary dive performance, that capability represented a fundamental tactical advantage that demanded immediate understanding and potential countermeasures. Diving attacks formed the foundation of German fighter tactics. Luftwaffe doctrine emphasized using altitude advantage to build speed for slashing attacks on bomber formations, then climbing back to altitude before escorts could respond. But if American escort fighters could follow German interceptors through those dives and remain fully controllable while doing so, the entire tactical framework became suspect. What made Beetle particularly valuable was its condition. Unlike most captured aircraft that arrived as damaged wrecks requiring extensive reconstruction, Roach's Thunderbolt needed only minor repairs and routine maintenance to become airworthy. The 2800 double Wasp engine was intact. The airframe showed no significant structural damage. The control systems appeared fully functional. German mechanics estimated they could have the aircraft flying within days rather than weeks, allowing comprehensive evaluation of its actual capabilities rather than theoretical speculation based on fragmentary combat reports. The P-47 Thunderbolt represented American aviation engineering at a crossroads. When Republic Aviation's design team began work in 1940 on what would become the Thunderbolt, they made fundamental decisions that would define everything about the aircraft. The central choice was building the fighter around the massive Pratt & Whitney 2800 double Wasp radial engine, an 18-cylinder power plant producing 2,000 horsepower, later boosted beyond 2,500 horsepower in some variants. To put that power in perspective, the Messerschmitt Bf 109G produced roughly 1,475 horsepower from its Daimler-Benz inline engine. Even the powerful Focke-Wulf 190A topped out around 1,700 horsepower. The Thunderbolt had raw power that German fighters simply couldn't match. But all that power came with consequences that challenged conventional fighter design philosophy. The P-47D, the most common production variant, weighed approximately 10,000 pounds empty and could reach 17,500 pounds fully loaded with fuel, ammunition, and ordnance. That made it roughly twice as heavy as a Bf 109. German engineers examining the captured aircraft found the weight almost incomprehensible. Their own design philosophy emphasized minimizing weight to maximize agility and climbing performance. The Americans had apparently taken the opposite approach, building what was essentially a flying tank that happened to have wings. The Thunderbolt's size stemmed partly from its turbocharger system, one of the aircraft's most sophisticated and revolutionary features. Unlike German fighters that used mechanically driven superchargers mounted directly on the engine, the P-47 employed a massive General Electric turbocharger located in the rear fuselage. Hot exhaust gas from the engine spun a turbine that drove a compressor, forcing air into the engine at high altitude where thin atmosphere would otherwise starve it of oxygen. This system required extensive ducting, pipes running the length of the fuselage carrying superheated exhaust gases backward and compressed air forward. The engineering was complex, heavy, and prone to leaks, but it gave the Thunderbolt phenomenal high-altitude performance. At 30,000 feet, where Messerschmitts and Focke-Wulfs gasped for air and lost power, the P-47 still produced maximum horsepower, maintaining speed and maneuverability that made it dominant in the thin air where bomber combat typically occurred. The fuselage itself was built with structural margins that seemed almost wasteful by German standards. Republic's engineers had studied combat damage reports from early warfighters and concluded that most fatal hits occurred in predictable locations: the engine, the cockpit, and the fuel system. So they armoured everything. The pilot sat behind a 1/4-inch steel plate on his seatback with bulletproof glass in front. More armour protected the engine from frontal attacks. The fuel tanks incorporated revolutionary self-sealing design with multiple layers of rubber that would swell and close bullet holes when exposed to fuel. Then there was the redundancy built into every system. The P-47 had multiple fuel pumps, backup electrical systems, and control cables routed through different parts of the airframe, so a single cannon hit couldn't sever them all simultaneously. The cooling system for that enormous engine was distributed across a large area, meaning localized damage wouldn't cause immediate overheating. German fighters, built for minimum weight and maximum performance, had no such redundancy. A single 20mm shell in the right place could destroy a Bf-109's cooling system, forcing the pilot to shut down the engine within minutes or risk catastrophic failure. But none of this information answered the specific question that brought Beetle to Reschling. How did this massive aircraft perform in dives? The reports from combat pilots seemed almost fantastical. German pilots claimed they'd initiated diving attacks to escape pursuing Thunderbolts, only to have the American fighters follow them down and actually gain ground during the descent. Other pilots reported that P-47 could enter vertical dives at full throttle and pull out at lower altitudes without losing control or suffering structural failure. These claims contradicted everything Luftwaffe pilots knew about high-speed flight. German fighters had severe limitations in dives. The Messerschmitt Bf-109 was officially redlined at 466 miles per hour indicated airspeed. Beyond that velocity, compressibility effect set in, control surfaces became progressively heavier and less responsive, and pilots risked losing control entirely. The phenomenon was well documented and deadly. Luftwaffe pilots attempting high-speed dives had flown straight into the ground when their elevators became unresponsive, locked by aerodynamic forces they couldn't overcome with physical strength alone. The Focke-Wulf 190 suffered similar limitations, experiencing severe compressibility problems above approximately 480 miles per hour. Both aircraft types could achieve higher velocities in steep dives, but doing so meant entering a dangerous flight regime where recovery became uncertain at best, impossible at worst. German tactical doctrine explicitly warned against prolonged high-speed dives because the risk of losing control exceeded any tactical advantage. Yet American pilots apparently dove their Thunderbolts routinely at velocities that would destroy German fighters or render them uncontrollable. If the combat reports were accurate, the P-47 remained stable and fully controllable at speeds approaching and exceeding 500 miles per hour, velocities where Messerschmitts and Focke-Wulfs were already experiencing critical compressibility effects. The question was simple. Was this actually true, or were combat conditions creating exaggerated perceptions? Reschling wasn't throwing random pilots at captured aircraft. The Luftwaffe maintained a specialized unit specifically tasked with evaluating enemy equipment. This organization, eventually formalized under the command of Theodor Rosarius and known as Zirkus Rosarius, had evolved by 1943 into one of the most elite technical units in the Luftwaffe, staffed by combat veterans who understood not just how to fly, but how to analyze an aircraft's strengths and weaknesses from an operational perspective. The test pilots selected for captured aircraft evaluation weren't peacetime test pilots concerned primarily with handling characteristics and performance data. They were warriors who'd survived hundreds of combat missions and possessed encyclopedic understanding of fighter tactics and capabilities. They could immediately recognize whether a design feature would matter in actual battle or was merely an Interesting technical detail with no operational significance. Hans-Werner Lersch was among the primary test pilots assigned to evaluate Beetle. By 1943, Lersch had established himself as one of Reichlin's most experienced and capable aviators, having flown more than 100 different aircraft types, including numerous captured Allied machines. He'd trained as both a pilot and an engineer, giving him technical understanding that complemented his flying skills. Lersch approached captured aircraft methodically, learning their systems through direct experimentation, since captured machines rarely came with pilot's notes or operating manuals. The evaluation process at Reichlin followed structured protocols, designed to extract maximum information while minimizing risk. First came walk-around inspections where pilots and engineers examined the aircraft's construction, noting design features, armament arrangements, and systems layout. They studied the cockpit carefully, identifying where American designers placed critical controls and how visibility compared to German fighters. Ground engine runs followed, allowing evaluation of the power plant's characteristics, responsiveness, and any unusual operating requirements. Only after these preliminary assessments would test pilots attempt flight operations, and even those followed careful progression. Short hops around the airfield came first. Basic takeoffs and landings to understand the aircraft's handling during critical phases of flight. If those initial flights revealed no dangerous characteristics, testing gradually expanded to aerobatic evaluation, high-speed runs, and simulated combat maneuvers. Every aspect was documented obsessively. German technicians photographed details, took measurements, compiled technical reports that would be distributed to aircraft manufacturers and Luftwaffe tactical commands across all fronts. Lersch squeezed himself into Beetle's cockpit and immediately understood why. American pilots needed reasonable height and arm length. The cockpit wasn't cramped in the claustrophobic sense that characterized the Bf-109. It actually had more internal volume than most German fighters. But everything was positioned for a pilot with longer limbs than the average German aviator. The rudder pedals sat far forward. The control stick rose from the floor at an unfamiliar angle. The instrument panel seemed to stretch away into the distance. German fighters wrapped around their pilots like tailored suits, every control positioned for minimum reach and maximum efficiency in the confined space. The Thunderbolt felt more like sitting in a small room, but the visibility was extraordinary. The bubble canopy introduced on the D model provided an almost 360-degree view that made the Bf-109's heavily framed canopy seem like peering through a prison cell window. Lersch could look directly behind himself without straining, scan above and below with minimal head movement, and had unobstructed views of both wingtips. In combat, this would provide enormous advantage. Most kills came from attacks the victim never saw coming. The P-47's canopy made surprise attacks significantly more difficult to achieve. The instrument layout initially baffled the German pilots. American designers had arranged everything differently. Airspeed displayed in miles per hour rather than kilometers. Altitude showed feet rather than meters. And there was a bewildering array of gauges for systems German fighters simply didn't have. Multiple fuel tank selectors because the P-47 carried fuel in the fuselage, wings, and external drop tanks, complex turbocharge controls with regulators and pressure gauge. The electrical panel alone had more switches than the entire cockpit of an early model Bf-109. It took Lersch several hours just to understand what everything did, and considerably longer to memorize the startup sequence. The armament switch panel revealed American philosophy about firepower, overwhelming volume. The P-47D carried 8 Browning Meadow 50 caliber machine guns, 4 in each wing, with approximately 425 rounds per gun. That translated to roughly 3,400 total rounds. By comparison, the FW-190-08 typically carried 4 20mm cannons and 2 13mm machine guns, with far less total ammunition. What surprised Lersch most during the initial inspection was the comfort. The seat was well padded, substantially better than the hard metal seats in Messerschmitts. The cockpit was heated effectively, important during high-altitude operations where temperatures dropped far below freezing. There was even a relief tube for long missions, a small detail that became significant on 4-hour escort missions to Berlin and back. German fighters were built for short-duration interceptions. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this, rarely staying airborne for more than 90 minutes. The P-47 was clearly designed for marathon missions, with ergonomics that prioritized pilot endurance over minimum weight. The 2800 Double Wasp roared to life with a deep, throaty bellow distinctly different from the high-pitched scream of a Daimler-Benz inline engine. Lersch let it warm according to procedures the mechanics had translated from captured American technical manuals, watching cylinder head temperature gauge climb into acceptable range. The entire aircraft vibrated with barely contained power, and he hadn't even advanced the throttle yet. When he finally released the brakes and taxied toward the grass field, the P-47's weight became immediately apparent. It didn't dance across the ground like a Bf-109 or even lumber like a fully loaded FW-190. It moved with deliberate momentum, requiring heavy brake applications to control speed and aggressive bursts of throttle to overcome inertia from a standstill. The takeoff roll was considerably longer than Lersch expected. The Thunderbolt accelerated steadily but not explosively, its weight requiring more distance than any single-engine fighter he'd flown. Around 100 miles per hour indicated airspeed. He eased back on the stick, and the P-47 lifted off smoothly, climbing away from Rechlin with stability that felt almost like flying a bomber. There was none of the twitchiness of a Bf-109, no tendency to swing on takeoff from engine torque like the powerful FW-190. The Thunderbolt just flew solid and predictable. At altitude, Lersch began exploring the aircraft's handling characteristics. He leveled off at 25,000 feet and started with basic maneuvers. The controls were heavier than German fighters. The ailerons required genuine muscle to move at high speed, and the elevator felt like it was moving through molasses compared to the light touch needed in a Bf-109. But there was precision in that heaviness. When Lersch commanded a turn, the P-47 responded exactly as much as he wanted, and then stopped, with no overcorrection, no bobbling or hunting. It was stable to the point of feeling almost reluctant to maneuver. This stability would be invaluable as a gun platform, he realized. German pilots often struggled to hold their aim during high-speed attacks because their fighters were so sensitive that tiny control inputs caused large movements. The Thunderbolt's heavy controls would keep the gun sight steady on target, even during aggressive maneuvering. Then Lersch decided to test what really mattered. The combat reports from Luftwaffe pilots all emphasized one characteristic: the P-47's diving performance. If that capability was real, it represented a fundamental tactical advantage that no amount of superior turning ability could overcome. He rolled the Thunderbolt inverted, pulled the nose down toward the vertical, and opened the throttle. The response was immediate and stunning. The airspeed indicator began climbing rapidly. 300 miles per hour, 350, 400. The Thunderbolt remained rock solid, no buffeting, no tendency to tuck or pull itself into a steeper dive. Lersch had experienced dives in Bf-109s and FW-190s. Both types became progressively more difficult to control as speed increased. Control forces grew heavier. The aircraft developed tendencies to pitch nose down as compressibility. Effects changed airflow over the wings and tail surfaces. Pilots had to fight the controls, using significant physical strength to maintain or change the dive angle. The P-47 exhibited none of these characteristics. 450 miles per hour, 475, 500. At velocities where German fighters would be experiencing severe compressibility problems, locked controls, and potentially structural concerns, the Thunderbolt still felt controllable. Lersch could move the control stick with effort, but the aircraft responded predictably to his inputs. There was no sensation of losing control or approaching dangerous limitations. He pulled back on the stick to recover from the dive. The Thunderbolt responded smoothly, converting its dive speed into a soaring climb that took him back up several thousand feet in seconds without requiring excessive G-forces or physical effort. This was the capability that made the P-47 so dangerous in combat. An attacking fighter could dive on its target with enormous speed, fire a quick burst, then use that accumulated velocity to zoom climb back to altitude before anyone could retaliate. The tactical implications were immediate and troubling. A P-47 pilot could dive faster than anything the Luftwaffe flew and sustain those speeds longer without losing control. A Bf-109 pilot trying to follow a diving Thunderbolt would either have to break off the pursuit or risk exceeding his aircraft's structural and aerodynamic limits. And if a German pilot somehow managed to stay with a diving P-47, the American could simply push the throttle forward and extend away, using superior dive acceleration to break contact before the pursuer could close to effective firing range. Reich conducted multiple dive tests over the following days, each time pushing the Thunderbolt slightly faster, slightly steeper, exploring the boundaries of its performance envelope. Other Reichlin test pilots flew the aircraft as well, each bringing their own combat experience and analytical perspective to the evaluation. The consensus formed quickly and unavoidably. The combat reports had been accurate. The P-47 possessed genuinely revolutionary dive performance that gave American pilots a decisive tactical advantage in specific combat situations. But understanding how the Thunderbolt achieved this capability required deeper analysis. German engineers began systematic examination of the aircraft's structure and aerodynamics, searching for the specific design features that enabled such extraordinary high-speed performance. The wing design provided the first clues. The P-47's wing was thick by fighter standards, with a relatively high aspect ratio that generated substantial lift. But Republic's engineers had carefully designed the airfoil section and wing planform to delay the onset of compressibility effects. German fighters like the Bf-109 and FW-190 had wings optimized for maneuverability and high-speed level flight, but their airfoil sections developed severe shock waves at relatively low Mach numbers. As airflow over these conventional wings approached the speed of sound locally, shock waves formed that disrupted smooth airflow, caused control surface blanking, and created powerful nose-down pitching moments that made recovery from high-speed dives extremely difficult. The P-47's wing design delayed these compressibility effects to higher velocities. The aircraft could dive faster before encountering the aerodynamic phenomena that made German fighters uncontrollable. Additionally, the Thunderbolt's sheer weight worked in its favor during dives. While heavy weight penalized climb performance and sustained turning ability, it provided advantage during acceleration in descents. Once the P-47 pointed its nose down, gravity and thrust combined to overcome drag more effectively than in lighter aircraft. The structural strength also became apparent during evaluation. German engineers examining the airframe discovered that Republic had built enormous safety margins into critical components. The wing spars, fuselage frames, and control surface attachments were all substantially stronger than equivalent structures in German fighters. This robust construction allowed the P-47 to sustain higher aerodynamic loads during high-speed flight and recovery from dives without risk of structural failure. Testing revealed specific dive characteristics that explained the combat reports. The Thunderbolt could enter vertical dives at full throttle and achieve indicated airspeeds exceeding 550 miles per hour at lower altitudes where air density was higher. At those velocities, the aircraft remained controllable enough for pilots to begin recovery without excessive physical effort. The elevator required strength to move, but it still moved. The aircraft responded to control inputs rather than ignoring them, as German fighters tended to do at comparable speeds. The zoom climb capability proved equally impressive. After diving to build tremendous speed, a P-47 pilot could convert that velocity into altitude gain that seemed almost impossible to German pilots accustomed to their own aircraft's limitations. The Thunderbolt would climb thousands of feet, trading speed for altitude with aerodynamic efficiency that German fighters couldn't match. This capability fundamentally changed the geometry of air combat. Traditional fighter tactics assumed that aircraft losing energy during maneuvering would need time to rebuild speed and altitude before re-engaging. The P-47 could rebuild both parameters so quickly that it remained dangerous, even after apparently defensive maneuvering. An American pilot could dive away from an unfavorable engagement, extend to safety, then zoom climb back to a position of advantage before the pursuing German pilot fully understood what had happened. Hans-Werner Lersch would later write about one particularly memorable incident during his P-47 test flying that illustrated both the aircraft's capabilities and its potential dangers. During a high-altitude flight between 29,500 and 36,000 feet, his oxygen supply apparently became insufficient. He experienced altitude sickness, that insidious condition where pilots feel increasingly drowsy without realizing the danger until consciousness begins slipping away. Lersch found himself at 13,000 feet with the engine throttled back, unable to remember the actual sequence of events that brought him there. He'd apparently entered an uncontrolled dive while semi-conscious from oxygen deprivation. But the Thunderbolt's inherent stability and structural strength had saved his life. Despite diving at high speed without pilot input, the aircraft hadn't broken up or entered an unrecoverable flight regime. Lersch regained awareness, carefully restarted the engine which had cooled during the descent, and landed safely at Rechlin. The incident highlighted a crucial difference between American and German design philosophy. German fighters required constant pilot attention and input. They were sensitive, responsive machines that rewarded skilled pilots but punished inattention or loss of consciousness immediately and catastrophically. The P-47 was stable enough to survive pilot incapacitation, at least temporarily. That stability, combined with robust construction, translated directly into pilot survivability in combat conditions where injury, hypoxia, or distraction could occur. Comprehensive evaluation of Beetle at Rechlin produced detailed technical reports that circulated through Luftwaffe tactical commands and aircraft development offices. The findings were unambiguous and deeply troubling from a German tactical perspective. The P-47 Thunderbolt possessed genuine and significant advantages in specific performance categories that mattered enormously in combat. High-speed diving performance, zoom climb capability, structural strength, and high-altitude power. These advantages weren't theoretical or marginal. They were substantial, decisive differences that fundamentally altered the tactical options available to both American and German pilots. A P-47 pilot who understood his aircraft's capabilities could choose when to fight and when to disengage. He could initiate attacks from positions of advantage and escape from unfavorable situations using performance capabilities. German fighters couldn't match. The reports emphasized that German fighters retained advantages in other areas. The Bf 109 could outturn the P-47 Pouce sustained turning fights at most altitudes and speeds. The FW 190 had better roll rate at moderate speeds. Both German types climbed more quickly from low altitudes, where the P-47's turbocharger provided no advantage. But these strengths became largely irrelevant if American pilots refused to engage in circumstances where German advantages mattered. The tactical implications rippled through Luftwaffe fighter commands like shock waves. Unit commanders who'd been receiving combat loss reports that seemed almost incomprehensible now had engineering data confirming what their pilots had been experiencing. German fighters were being outperformed in the specific areas that determined whether a pilot could control the terms of engagement. Luftwaffe tactical doctrine began adapting immediately, though adaptation could only mitigate rather than eliminate the performance disparity. Fighter pilots received specific instructions about engaging P-47. Avoid prolonged stern chasse where the American could simply accelerate away. Never attempt to follow a diving Thunderbolt unless altitude permitted breaking off before reaching dangerous speeds. Don't assume a damaged or retreating P-47 is helpless. The aircraft could absorb tremendous punishment and still remain flyable. Attack from head-on when possible, where the encounter happened so quickly that neither aircraft's specific advantages mattered as much as pilot skill and marksmanship. Focus on bomber interception rather than fighting escorts. If P-47 were too difficult to kill efficiently, concentrate on destroying the B-17 and B-24 they protected. Use superior numbers to draw escorts away from bomber formations, creating windows for other German fighters to attack the bombers without interference. But these tactical adjustments couldn't change the fundamental reality that Rechlin's testing had confirmed. American aviation engineering had produced a fighter that excelled at the specific mission it was designed to accomplish. The P-47 wasn't the best dogfighter. It wasn't the fastest in level flight. It didn't climb most quickly or turn most tightly, but it was extraordinarily difficult to shoot down, could escort bombers to any target in Europe, and possessed dive performance that made it nearly impossible for German fighters to catch or escape once combat was joined. The psychological impact on Luftwaffe pilots, who learned about Rechlin's findings, extended beyond simple tactical concerns. These men had entered the war confident in German technological superiority and the quality of their aircraft. By mid-1943, extensive combat experience combined with detailed testing of captured American fighters had systematically eroded that confidence. They recognized with uncomfortable clarity that they faced opponents who possessed decisive advantages in areas that determined survival. The knowledge gained from testing Beetle spread through the Luftwaffe's operational units via the Circus Rosarius demonstration program. After completing evaluation at Rechlin, captured Allied aircraft were released to this specialized unit commanded by Flugkapitän Theodor Rosarius. The organization traveled to operational Luftwaffe fighter bases across Germany and occupied territories, bringing captured aircraft directly to frontline pilots who would face them in combat. The demonstrations followed a carefully structured format designed to maximize educational value. The captured P-47 would taxi past assembled German pilots and ground personnel, creating surreal scenes as an enemy fighter bearing German markings and bright yellow identification paint moved among Messerschmitts and Focke-Wulfs. Seeing the aircraft up close had substantial psychological impact, making the enemy tangible and real rather than abstract reports in intelligence briefings. Then came flight demonstrations where experienced test pilots would fly the Thunderbolt through carefully choreographed routines designed to illustrate specific capabilities. High-speed passes at low altitude dramatically showed the aircraft's velocity advantage. Climbing maneuvers demonstrated the remarkable high-altitude performance enabled by turbocharging. Diving attacks illustrated the characteristic that made the P-47 so dangerous: its ability to build tremendous speed in descents while remaining fully controllable. Mock dogfights against German fighters provided the most valuable instruction. Selected Luftwaffe pilots would fly their operational Messerschmitts and Focke-Wulfs against the captured Thunderbolt in carefully controlled simulated combat. These exercises weren't demonstrations of superiority, but honest assessments of relative capabilities. The German test pilot flying the P-47 would employ tactics that American pilots typically used in actual combat, maintaining energy advantage, refusing to enter sustained turning fights, using superior dive performance to disengage when threatened. German pilots flying against the Thunderbolt quickly discovered the extreme difficulty of successfully engaging an opponent who understood and exploited the P-47's specific advantages. When they pursued aggressively, the Thunderbolt simply accelerated away, opening distance faster than pursuing German fighters could close it. When they attempted to climb above the P-47 for diving attacks, the American fighter's superior high-altitude performance allowed it to reach advantageous positions first. When German pilots tried to force sustained turning fights, where the Bf-109's superior agility should have provided decisive advantage, the Thunderbolt pilot would refuse the engagement by extending away using superior speed, then reverse back with renewed energy advantage when conditions favored attack. The demonstrations proved sobering for German pilots, who had believed or hoped their aircraft and tactics remained reasonably competitive despite deteriorating strategic circumstances. After flight demonstrations concluded, pilots and ground personnel could approach the aircraft, examine it closely, inspect the cockpit layout, and ask detailed questions of test pilots who had extensive experience flying the captured machine. These hands-on sessions proved invaluable for demystifying enemy aircraft and providing concrete understanding of what German pilots would face in operational combat. The most impactful component of base visits involved selected, experienced German pilots actually flying the captured P-47 themselves under supervision. This direct experience proved far more effective than any briefing or written report could ever be. Pilots who flew the Thunderbolt came away with visceral understanding of its capabilities and limitations. They learned firsthand how the heavy controls felt at high speed, how quickly the aircraft accelerated in dives, how much altitude it could gain in zoom climbs. One such demonstration visit occurred at a base hosting a frontline fighter unit during late 1943. The unit commander arranged for several of his most experienced pilots to fly mock engagements against the captured Thunderbolt to gain practical knowledge they could pass to squadron mates. The German pilots attempted standard Luftwaffe tactics that had proven effective against earlier Allied fighters. They quickly discovered those established methods simply didn't work against a P-47, whose pilot properly exploited the aircraft's performance advantages. The pattern repeated itself across numerous bases where Circus Rosarius conducted demonstrations throughout late 1943 and into 1944. German pilots received official assurance during pre-demonstration briefings about continuing superiority or at least competitive parity of their aircraft. Then they experienced actual flight demonstrations and mock combat that directly contradicted those optimistic assessments. The captured aircraft provided concrete, undeniable evidence that German fighters faced formidable opponents whose capabilities significantly exceeded what propaganda suggested. But knowledge alone couldn't overcome the fundamental disadvantages German forces faced by mid-1944. Understanding intellectually that the P-47 could outrun, outdive, and dramatically outrange German fighters offered limited practical benefit when German pilots still had to engage these superior aircraft in defense of German territory under direct orders. The Luftwaffe suffered from chronic and worsening fuel shortages that severely limited training hours for new pilots, resulting in inadequately prepared aviators being sent into combat with minimal experience. Experienced pilots who understood through hard-won combat experience how to fight effectively against aircraft like the P-47 were increasingly rare, lost to relentless attrition during the brutal air combat of 1944. Aircraft production, while remaining surprisingly high despite intensive Allied strategic bombing, could not replace loss quickly enough to maintain force strength. Most critically, the strategic situation had deteriorated beyond any possibility of reversal through tactical innovation or improved pilot training. The P-47's dive performance represented just one element of a broader pattern where American aviation engineering had produced aircraft optimized for their specific missions. The Republic design team hadn't tried to create the perfect fighter that excelled in every performance category. They'd built an aircraft specifically designed for long-range bomber escort that could fight its way to Berlin and back, survive combat damage that would destroy lighter fighters, and give its pilot tactical options that included choosing when to fight and when to disengage. That design philosophy reflected American strategic thinking about the air war. The United States possessed industrial capacity to build heavier, more complex fighters in vast quantities. American training programs produced pilots with hundreds of hours of flight time before they entered combat. American logistics could support operations requiring thousands of gallons of fuel per sortie. The P-47 was designed to leverage these strategic advantages, rather than trying to match German fighters in areas where German design philosophy had traditionally excelled. The Thunderbolt's exceptional dive speed wasn't an accident or fortunate byproduct of other design choices. It was a deliberate feature enabled by specific engineering decisions. The robust airframe structure that could withstand high aerodynamic loads, the wing design that delayed compressibility effects to higher velocities, the powerful engine that could add thrust to gravitational acceleration during descents, and the control systems that remained responsive even at speeds where many fighters became uncontrollable. German aviation, engineers studying the technical reports from Reich understood these design choices and their implications. Several late-war German fighter programs attempted to incorporate lessons learned from captured American aircraft. The Ta-152 high-altitude fighter included strengthened structures and improved high-speed handling. Various jet and rocket-powered designs incorporated features intended to address weaknesses that testing had revealed in conventional German fighters. But implementing improvements required retooling factories, redesigning aircraft from scratch, and diverting resources from immediate production to development programs that wouldn't yield operational aircraft for months or years. Germany didn't have time, materials, or industrial capacity to follow America's example. They could only document what they'd learned and hope that incremental improvements might narrow performance gaps that were becoming chasms. The strategic air campaign over Germany succeeded in large part specifically because of fighters like the P-47 Thunderbolt and later the P-50, a Mustang that could escort heavy bombers throughout complete missions to any target in German-controlled territory. Long-range bomber escort deep into Germany remained operationally infeasible until these aircraft arrived in substantial quantities during early to mid-1944 and began flying operational missions. Previous Allied escort fighters like early model P-47 without drop tanks and the P-38 Lightning, despite considerable capabilities in other areas, possessed insufficient range to accompany heavy bombers on missions to the most distant and heavily defended targets. This critical limitation allowed German fighters to wait until escorts reached their fuel limits and turned back toward their bases before attacking bomber formations during the most dangerous portions of missions. The introduction of longer-range P-47 equipped with external fuel tanks, followed by the even longer-ranged P-50 and Mustang, fundamentally transformed bomber escort operations. German fighters could no longer find extended periods when bombers flew without protective escorts. This operational reality forced German pilots to engage American fighters directly rather than simply attacking bombers, dramatically increasing the risk German aviators faced on every interception mission. The Thunderbolt that Second Lieutenant Hobert Roach accidentally landed at Caen on that June morning in 1943 served its educational purpose well. After comprehensive testing at Rechlin and extensive demonstration tour with Circus Rosarius, Beetle provided hands-on experience to hundreds of Luftwaffe personnel. The aircraft gave German pilots realistic understanding of what they would face in combat, though that knowledge primarily confirmed what many already suspected. Allied aircraft possessed significant and decisive performance advantages that German industry and engineering could not match during the war's final years, given resource constraints and strategic circumstances. The fate of the specific aircraft remains somewhat unclear in historical records. Circus Rosarius continued operating into early 1945 and conducting demonstrations with various captured aircraft as long as aviation fuel remained available in sufficient quantities and operational airfields could be maintained against Allied advances from both east and west. Eventually, the program ceased operations as the general collapse of German military organization overtook even specialized units that had previously received priority for scarce resources. Some captured aircraft were destroyed on the ground during Allied air raids against German airfields that intensified dramatically during 1945. Others may have been deliberately destroyed by retreating German forces to prevent recapture by rapidly advancing Allied armies. A few possibly survived until war's end and were subsequently recovered by Allied force, though detailed records of such recoveries remain limited. The legacy of that captured P-47 extended far beyond its immediate tactical intelligence value. The testing at Rechlin and demonstrations by Circus Rosarius represented sophisticated and professional approaches to understanding enemy capabilities despite Germany's deteriorating strategic position. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, German forces invested significant and scarce resources in systematically flying captured Allied aircraft under controlled conditions. This methodical approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately. The program continued even as Germany's strategic situation became increasingly hopeless, reflecting professional competence and systematic analysis that persisted despite mounting evidence of inevitable defeat. But the experience also demonstrated that sophisticated intelligence gathering, professional competence, and systematic analysis could not overcome fundamental material and strategic disadvantages. German pilots who flew captured Thunderbolts gained valuable knowledge about aircraft characteristics and optimal tactics. Yet that hard-won knowledge primarily confirmed uncomfortable realities rather than revealing exploitable weaknesses. The P-47's extraordinary dive performance represented tangible evidence that American engineering had achieved genuine technological advantages in specific critical areas. This wasn't propaganda or exaggeration. It was measurable, demonstrable capability that German test pilots experienced directly and could not dismiss or explain away through ideological assumptions about American industrial inferiority. The admission by experienced Luftwaffe test pilots that they had never encountered dive speed like the P-47's represented professional acknowledgement of American engineering achievement and realistic recognition of the significant performance gaps German pilots faced in combat operations. This acknowledgement, forced by direct personal experience rather than second-hand intelligence reports, illustrated how confronting uncomfortable realities sometimes requires hands-on experience that cannot be dismissed through wishful thinking. The story of German pilots flying a captured P-47 and discovering its revolutionary dive performance captures a broader truth about the air war over Europe during World War II's latter stages. Individual pilot skill and courage remained critically important, but they operated within constraints imposed by aircraft capabilities and strategic resources. When one side possessed decisive advantages in key performance areas while also enjoying overwhelming numerical superiority, better logistics, and more thorough training, the outcome became inevitable, regardless of tactical innovation or determination. The Thunderbolt, sitting on that grass field at Rechlin, its massive radial engine silent after another test flight, its yellow-painted undersides bright in the German sun, represented more than just one captured aircraft. It embodied the collision between German expectations and American capabilities, between what Luftwaffe pilots hoped was true about their technological position and what they discovered through direct experience was actually true. When those German test pilots climbed from the P-47's cockpit after diving it to speeds that would have destroyed their own fighters, when they admitted to themselves and their superiors that American engineering had produced something genuinely superior in this specific and critical capability, they were acknowledging a shift in the balance of technological and industrial power that would influence not just the remainder of World War II, but the entire post-war era. The dive speed that so impressed and troubled those German pilots wasn't just about one aircraft's performance characteristic, it was about what that capability represented: American industrial might, engineering sophistication, and strategic thinking that had produced weapons systems optimized for their specific missions, built in quantities that overwhelmed opponents, and flown by pilots with training and support that maximized effectiveness. Second Lieutenant Roach eventually returned home after the war, released from prisoner-of-war camps when Germany surrendered. His aircraft, the P-47 he'd accidentally landed at an enemy airfield on what should have been a routine mission, had served a purpose neither he nor his commanders could have anticipated. Beetle had become an instrument of revelation, forcing German pilots to confront capabilities they couldn't match and acknowledge advantages they couldn't overcome. The lessons learned from that captured Thunderbolt rippled forward through aviation history. Modern fighter design still emphasizes structural strength, control authority at high speeds, and capability to recover from extreme flight conditions. The philosophy that produced the P-47 building aircraft robust enough to survive the chaos of combat while giving pilots options to control engagement. Geometry continues influencing military aviation development into the 21st century. When we look at photographs of that captured P-47 sitting at Rechlin surrounded by German pilots and technicians, we're seeing more than just another intelligence-gathering operation. We're witnessing the moment when professional military aviators set aside propaganda and ideology to honestly assess their opponent's capabilities. We're observing the recognition that technical excellence existed on both sides of the conflict, but that American industrial capacity and strategic resources had produced advantages that skill and determination alone could not overcome. The German pilots who flew that captured Thunderbolt and admitted they'd have never seen dive speed like it were performing an act of professional honesty that deserves recognition. They could have dismissed the reports, attributed American success to luck or numbers, or insisted that German fighters remained superior despite mounting evidence to the contrary. Instead, they conducted systematic testing, documented their findings objectively, and disseminated information that would help their fellow pilots survive, even though it confirmed uncomfortable truths about the strategic situation they faced. That captured P-47 taught German pilots what American engineering could achieve when industrial might, technological sophistication, and clear strategic thinking combined to produce weapon systems designed for specific missions. It demonstrated that dive performance wasn't just about going fast downward, it was about maintaining control at those speeds, surviving the stresses those velocities imposed, and retaining options when other pilots found themselves locked into unrecoverable situations. And perhaps most importantly, it showed that honest assessment of enemy capabilities, even when that assessment revealed one's own disadvantages, represented the mark of professional military competence. The German pilots who climbed into that captured Thunderbolt, pushed it into vertical dives at full throttle, felt it accelerate to speeds their own fighters couldn't match, and then reported exactly what they'd experienced were doing their duty with integrity that transcended national allegiance or wartime propaganda. The P-47 Thunderbolt proved itself in combat across every theatre of World War II, from the skies over Europe to the Pacific Islands, from ground attack missions to high-altitude bomber escort. But perhaps its most important mission was the one it flew at Rechlin in German hands, teaching enemy pilots that American aviation had achieved capabilities they'd underestimated, and that the balance of technological power had shifted in ways that would determine not just the war's outcome, but the shape of the world that would emerge from the conflict. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.